Okay, so the third problem we're going to be doing as an example is shown over here, and is basically a tank connected to a manometer. All right, but like I always show you, this might be the last time. In order to solve the problems, I always follow the same procedure. First, I do some type of figure after I read the problem, in which I put all the information that is given to me and what I need to find. So basically, after doing this step, I should not, if I did it right, I should be able to solve the problem without going to the problem statement. Then I do the appropriate figures that will going to help me to write down the main equation or equations initially to solve the problem. If with this equation or equations I have enough information to solve the problem, I just go directly to step 4. But if I don't have enough information after step 2, I go to step 3, where I try to find all the additional equations or conditions that are necessary in order to solve the problem. Okay? All right, so let's solve over here the problem. So you see I have the figure, I have the problem statement. A lot of people think that it's a waste of time, but you know, to do this step 0 gives you time to think about the problem. So let's see, I like to do the figure even before I start reading the problem. Alright, so this is the manometer, so this, and I'll go up. And I'll go up. Okay. So over here we have pressure gauge. Okay, so this is oil. That is going to be up to here. Alright, so this is oil. And then we have mercury over here. Mercury. Hg is the chemical symbol for mercury. Then we have, they give us here some dimensions, so L1 equals 3 feet, L2 equals to half a foot, and L3 equals 3/4 of a foot. Alright, so we know the distance between here and here, this is L1. Between here and here would be L2. And between here and here will be L3. Okay, and over here, this will be subjected to the outside atmospheric pressure, and here will be the pressure of the air in the tank. So what else do we have on the problem? We know G equals to 32.2 feet 7 square. Density of oil 55 pound mass cubic feet, and density of mercury 845 pounds. Okay, so what do we need to solve for? Determine the reading of the pressure gauge. Okay, so we need to find reading in lbf inch square. So if I did it right, at this point I should be able to take this page away and never have to look at it again. Okay, if I did it right. Sometimes I forget to put some information. So now let's go to step 0. In this case, step 0 looks like it's going to be an identical figure to this one, but let's try to make more clear all this area over there. Okay, so this is the part that I'm really interested. Okay. All right. PR is over here. P gauge is what we're trying to find over here. We know this is the P atmosphere. Oil goes up to here. Maybe I should have done a better effort over here to make this actually a little bit deeper, but too late now. L1, L2, and let's say this will be then L3. Okay, so remember that that the trick in all these problems about manometers is to recognize that within a fluid, so the pressure at this point over here within the orange fluid, let's call it A, will be the same as the pressure over the orange fluid at the same level, at the same height. So the pressure here should also be equal to PA. All right, so now we can go to step. So sorry, it was step 0, step 1, step 2. Okay, so now let's see. So let's start from this end and go this way, or we could start from this end and go that way. So let's try to find what is the pressure at point A when we start from this end. So we know it should be equal to P air plus or minus density of the oil G H, and H in this case will be equal to what? L1 plus L2. So L1 H is equal to L1 plus L2. Okay, the change in height. So now, what is the pressure higher, here or here? It's going to be here, because in addition here to the pressure of air, you have all the weight of the fluid, which is creating pressure at point A. So this should be plus. And now we can go, if you want, from point A to the P atmosphere. So we can say that the P atmosphere, in this case, will be equal to what? PA. So the pressure at this point is PA, and now we're moving up. So that means that the pressure here at point A is this much higher of rho G of mercury times L3 than over here. So we need to put minus rho mercury G L3. Okay? So now, if we just substitute this equation into here, let's see what we get. Let me go to the next page. So we'll get over here, let's say P atmosphere will be equal to PA, which is equal to P air plus rho oil G L1 plus L2 minus rho mercury G L3. Okay, so this will give us what? P atmospheres equals P air plus, let's say, a factor by G of raw oil L1 plus L2 minus raw mercury times L3. Okay, so in the problem they ask us to find P gauge, which is over here. So what is P gauge? P gauge should be the difference in pressure between the air and the atmosphere. Okay, so that means that what we need to find over here is that P gauge will be equal to P air minus P atmosphere. Okay, so P air, so basically means that I move P atmosphere to this side and I move all this term to the other side. So that means at the end I will have G factor of raw density of mercury L3 minus density of the oil L1 plus L2. Okay? Okay, so we know the densities, we know the length, so we can find the numerical value. So step 4, solve. This is also part of the solve, but let's just say numerical solution. Alright, so P gauge will be equal to G, which is 32.2 feet 7 square times density of the oil is 845 pound-force cubic feet times L3 is 0.75 feet minus 55 lb cubic feet times L1 plus L2, which is let's see the problem statement again. L1, L2, okay, so L1 plus L2 will be equal to 3.5 feet. Alright, so if we do this calculation, I'm going to stop the video for a second to do the calculation. So I'm looking here at the result of my calculator that will give you 14208.25. And what would be the units? So we'll have, so we need to be careful here because I see we have feet times feet, okay, divided by cubic feet. So we'll have pounds on top divided by feet second square. Okay, but that's not what we need to find. We need to find at the end the pressure in basically PSI, pound force over inch square. So over here is where it comes handy to have one of these unit transformation pages. Might not be too clear, But I found this one online. Basically gives you some transformation, and here we look at the force. It's telling you what that 1 pound force is equal to 32.174 pounds per foot divided by second square. Okay, so that's the unit transformation we're going to use. So basically is, maybe I can use a different color. That page is telling you that 1 lbf is equal to 32.174 lb per foot second square. So now if you pay attention over here, what's going to happen? This one will cancel this one, this second square will cancel this one, and we end up with lbf foot square. And then so we end up with a foot square at the top. So we know that 1 foot is equal to what? 12 inches. So 1 foot square will be equal to 12 square inch square, which is 144. So this, if we do the calculation, again, I'm going to stop the video as I do the calculation for a second. So I get 3.0667, so let's say 3.07 lbf this one will cancel, inch square. So basically at the end, the pressure gauge on top of the tank over here should read 3.07 psi. Okay, so that would be all.